Starting with example 1, now we want to apply the fundamental theorem of calculus to find the value of these definite integral statements. In example 1, we're given the function f of x equals 3. In part A, we want to find the indefinite integral of that function f of x, meaning we want to find the indefinite integral of 3 dx, which will be 3x plus that constant c, always needs to be included there. Now that we have that indefinite integral, or the antiderivative, what we can do is evaluate this function at x equals 4, at x equals 0, and then subtract those two results. That means we want to evaluate 3x plus c at x equals 4, and then we're going to subtract, evaluating that same expression at x equals 0 to get 12 plus c minus 0 minus c, because keep in mind that negative will distribute through that set of parentheses. Plus c minus c will cancel out. The plus c and minus c will always cancel out with every definite integral problem. So it's okay that it's this unknown constant. When we evaluate the definite integral, it always just disappears or cancels out with the other value. So what we get is 12. The area under this curve between 0 and 4 is 12 square units. We can do that again with the function 2x. In this case, to integrate, this would become 2 times x to the second divided by 2 plus that constant c. 2 over 2 will reduce, so this will become x squared plus c. We need plus c in there as part of the indefinite integral, but we know once we start evaluating the definite integral, the c's will always cancel. So to evaluate the definite integral, we only need to evaluate the terms that aren't that constant. So we can just evaluate 4 squared, and we'll subtract negative 1 squared to get 16 minus 1. Since negative 1 squared will become a positive 1, we're still subtracting 1, and we'll get an area of 15 square units. In example 3, we have the function negative 5x to the negative third. This will become negative 5x to the negative second divided by negative 2 plus some constant c. So we get positive 5 halves x to the negative second plus c as that indefinite integral. Then to evaluate the definite integral, we evaluate that function at the upper bound. So 5 halves times 2 to the negative 2 power minus 5 halves times negative 5 to the negative second power. This will give us 5 halves times 1 over 2 squared, which will be 4, minus 5 halves times 1 over negative 5 squared, or 1 over 25, which will give us 5/8 minus 1/10, or 0.525.